This is an oral communication submitted to the first International Conference on Sustainable Energy and Advanced Materials. This oral communication was submitted to the topic of advanced material for materials and sustainable chemistry. I am hentabli Salma. I am affiliated to the Laboratory of Experimental Biology and Pharmacology for the Faculty of Sciences in the University of Yahya Faris Media in Media. For this communication, I wanted to talk about some of my work, which is about the formulation and evaluation of polyelectrolyte complexes based transdermal drug delivery system. Now, the objective of this study was to formulate piroxicam transdermal patches using biopolymers. Piroxicam is a medicine which is a principal active used for the treatment of arthritis. We used this piroxicam to control the release of it. So the objective of the study was to formulate piroxicam transdermal patches using biopolymers. Ketozan and xanthangam are used as a matrix system that encapsulates piroxicam and controls the drug release. And all of the prepared patches were assessed for their physicochemical parameters and in vitro drug release. As you can see in diagram number 1, the patches were prepared by mixing ketozan solution and xanthangam solution. For ketozan, it was mixed, or it was prepared in acetic acid, while xanthangam was dissolved in water, in distillated water. Both of these mixtures were mixed using a magnetic stirring in a water bath at 50 degrees Celsius. After that, they were homogenized and emulsified using a homogenizer at 1002 per minute for 2 minutes. And then twin ET was added as a permeability enhancer. All of the mixture was poured into a backing membrane and dried at 40 degrees Celsius for 12 hours. 5 different formulations were prepared, and as you can see in table number 1, the composition of the prepared patches, where we used 5 films. They all contain the same amount of piroxicam. However, ketozan and xanthangam were different. Each formulation has a different quantity or a different amount of ketozan and xanthangam. Twin was fixed through the whole experience. PG was also fixed through the whole experience with distillated water, and each formulation had a different rapport for ketozan and xanthangam. After that, all of the prepared patches were assessed for their chemical and physicochemical properties like flexibility, thickness, weight variation, moisture uptake, moisture content, and tensile strength. The in vitro drug release and ex vivo skin permission studies were also performed on the prepared batches. As now we are going to see the results. In the results section, all the results indicated that all of the patches exhibited good film consistency and good physicochemical properties. As you can see in figure 1, the physical aspect of these transdermal patches were transparent films, smooth, flexible, with good mechanical strength and a high bioadhesiveness. Now, for their physicochemical parameter, it was noted that in F3 and F4, the tensile strength gradually increased from 1.200 kilogram per centimeter to actually 1.82, where high ratios of the polymer were used, as table 2 represents all of these chemical parameters of piroxicam transdermal patches. You can see that the thickness was a little bit stable through the whole 5 films. The drug content was also a little bit different, and the tensile strength gradually increased when higher ratio of the polymers were used, and the adhesiveness of these films was also varied when higher content of the polymers were used. The release time T10 and T50 and T90, which correspond respectively to the times of release of 10%, 50%, and 90% of the drug, is represented in Figure 2, while Figure 3 shows the drug permission kinetics of the transdermal films through the rat skin. As you can see that F3 released 99.97% of the drug in 48 hours, and it was chosen as the best formulation. Now, while the other formulation have higher drug release in different times, for example, when you see formulation number 1, 100% of the drug was released in only 15 hours, while for F3, as I said, 99.97 was released for 48 hours, which is a very good result. Now, through this study, it was demonstrated that piroxicam transdermal patches formed by biopolymers blends may be a suitable device for transdermal administration in terms of pharmacokinetics and physicochemical properties. These transdermal films, composed with both chitosan and xanthan gum as a polymeric matrix, were transparent films, smooth and flexible with good mechanical strength. The drug release characteristic provided as the released